In this video, we're going to take a look at an example of chi-square goodness of fit hypothesis testing. And for chi-square goodness of fit, you'll actually encounter two different types of scenarios. In one scenario, you have equal proportions, and in the second, you have specific proportions. This particular video is going to look at the scenario where you have equal proportions. Many of you seem to be having trouble identifying the null hypothesis and the alternative hypothesis, one of which has to be stated in the given scenario. In the case of chi-square goodness of fit, that null hypothesis will contain equal. That's the only option you have. And so in the scenario, you want to look for phrases like equal frequency, equally distributed, there is no difference, are the same, or no preference. The alternative, which is the opposite of the null, will contain not equal in the chi-square goodness of fit scenario. You don't have to worry about less than, greater than, or so forth. It's going to be equal in the null and not equal in the alternative. And the phrases that you might see in the scenario are words like differs, is a difference, are not the same, not equally distributed, or possibly is a preference. Okay, so we're going to take a look at an example, and I'm going to walk you through the process. So example 1 says, a researcher wishes to see if the 5 ways people combat midday drowsiness are equally distributed among office workers. The 5 ways people use are drinking caffeinated beverages, taking a nap, going for a walk, eating a sugary snack, and other. A sample of 60 office workers is selected and the following data obtained. At alpha equals 0.10, can it be concluded that there is no preference? Okay, so when you're trying to identify the hypothesis for any hypothesis test, not just chi-squared, you want to look for keywords like conclude, believe, think, want to know. And typically the phrase after that keyword is going to be your hypothesis. So in this case, I see the keyword concluded near the end of the problem, and it says there is no preference. So we're trying to test the claim that there's no preference in the method used to combat midday drowsiness. So if we want to state our null hypothesis and our alternative hypothesis, again, the null will contain equal, and in this case, equal means there is no preference. If there's no preference, that means everything's the same. So we could actually write there is no preference in the ways used to combat midday drowsiness. So you can write the hypothesis for the chi-square goodness of fit in words. If you prefer symbols, the same thing can be written in symbols, and we're basically saying that the proportion that drink a caffeinated beverage is the same or equal to the proportion that take a nap, which is equal to the proportion who go for a walk, which is equal to the proportion who eat a sugary snack, which is equal to the proportion of other. And then you have to think about what that proportion value is going to be. And in this case, it's 1 out of 5. The formula for figuring the proportion is always 1 over the number of categories. In this case, I had 5 options, so it's 1 out of 5, or 20%. We know that the alternative hypothesis would be the opposite. So the opposite of there is no preference would be to say there is a preference, that one method is preferred over the other in the ways used to combat midday drowsiness. Now, again, it's okay to write this out in a sentence. Again, the null implies that it's equal. The alternative implies that it's not equal. If you prefer the symbols, we would simply say at least one of our proportions, and the generic is P with a subscript of I, does not equal 1/5. Okay, and they've given us the results. They surveyed 60 employees, so we know that our sample size is 60, and they tell us to use alpha is 0.10. So the next thing that we want to do is we need to figure the expected value for each category. So if you look at that table that we have above, okay, you have the way in which they combat midday drowsiness, okay, which was the beverage, nap, walk, snack, or other. And then we have the actual survey results when we surveyed 60 of the employees. You had 21 drink a beverage, 16 a nap, 10 go for a walk, 8 and 5. 8 do a snack, and 5 do other. Okay, and for each of those categories, then, we have to figure out how many should we have expected. The value that you're given in the table is what we observed. So this is our observed. This list here that was given to us is our observed. This is like the reality. This is what really happened when we conducted the survey. To calculate our chi-square, we need to know theoretically, if there really is no preference, how many of the employees should have used beverage, or how many would have used nap, and so forth. It's a formula. The formula for calculating the expected for chi-square goodness of fit is your sample size. Oops, excuse me. Okay, is your sample size times the proportion. And since this is equal proportion, the proportion will actually be the same across the board regardless of the category. So we surveyed 60 people, and there's a 1 in 5 chance that they would use a beverage to combat midday drowsiness. So 60 times 1/5 is 12. For a nap, again, there were 60 people. There's a 1 in 5 chance they're going to take a nap. So that's 12. 60 people total in our survey. 1 out of 5 chance they're going to go for a walk. Again, that's 12. 60 people in the survey. 1 in 5 chance they're going to eat a sugary snack. That's 12. 60 people in the survey. 1 in 5 chance they do something else. And again, that's 12. So when you have equal proportions, the expected value is the same for each category. We then are going to take that information in this table that I just created here, okay, in this table that I just created using the observed and the expected, and we're going to enter it into the calculator. And we need the calculator for chi-square goodness of fit. Okay, so the link was on the other PowerPoint. I'll try to add it at the end. Chi-square goodness of fit. The first thing you enter are the categories. So we had beverage, nap, go for a walk, eat a sugary snack, and other. So you type in the categories, click next, and then you need to enter the observed and the expected. We observed 21 people drank a beverage, we expected 12. 16 took a nap, we expected 12. 10 went for a walk, we expected 12. 8 ate a snack, 12 expected. 5 did something else, but 12 was expected. Now, they ask us in the problem to use 0.10 significance level. This calculator only allows for 0.01 or 0.05. I'm going to leave it at 0.05. Once I've entered the information, I'm going to click on calculate. Okay, when I get finished calculating, underneath this table, it tells me that my chi-square value is 13.833. So I'm going to write that down. That's one of the questions that we usually ask. So my chi-square test statistic is 13.833. Okay, so my chi-square goodness of fit test statistic is 13.833. And the corresponding p-value, which is also given to you on the computer screen, is 0.00785. So my p-value is 0.00785. Then the process continues just like it did for all the other hypothesis tests. We want to compare that p-value of 0.00785 to the given level of significance, which is 0.10 or 0.10. Well, p is less than alpha, and if p is less than alpha, we reject the null. So if we reject the null, then we got to think about what that means. So at the 0.10 level of significance, we're trying to say the null says there is not a preference, but we've rejected that, which means the null is false or wrong. So at the 0.10 level of significance, there actually is a preference. There is a preference in the ways used to combat midday drowsiness. Now, what chi-square goodness of fit does not tell us is it does not tell us which one of the methods is preferred. It would require further test for us to make that decision. Okay, so this is one example of equal proportions for the chi-square goodness of fit test.